Just a real quick explanation to wrap up all the operations on complex numbers. Really, when we work with polynomials and finding zeros of polynomials, which is why we want to introduce complex numbers now, we actually don't need division. But heck, we've already added, subtracted, multiplied complex numbers. It seems appropriate to at least put a button on the basic operations and talk about division. So in this case right here, we're dividing two complex numbers, 4 minus 3i divided by 8 plus 7i. And again, really important to remember is that we expect from this result to get out a complex number. When we're dividing these, importantly what we do is the fast, efficient algorithm for doing this is to not think of it in division as in this terms right here, but write it as a fraction, which we can always do to represent division. And why this is useful is we're now going to employ this technique of this complex conjugates that we had a second ago. The move that we're going to talk about is we're going to multiply by the complex conjugate of the denominator. And what this will end up doing is making the denominator a real number. And you're going to see the consequence of that. But again, so we're going to multiply by 8 minus 7i in this case to both the numerator and the denominator. Again, thinking of this division as a fraction of these two right here. When I multiply these out, again, I'm just doing distribution or foiling of all of this. In the numerator, I get 32 minus 28i minus 24i plus 21i squared. In the denominator, I'm going to write this just in terms of knowing what this multiplies to, because it's a bit quicker here. I've set this up to multiply perfectly. We're multiplying two conjugates. I always get this squared minus this second term squared. So this becomes 64 minus 49i squared. Now what I'm going to do is just clean up the numerator and the denominator. So I'm going to actually write this all out. I'll combine these like terms, but importantly, I want to deal with these I squareds, which we know are just a factor of -1. So right here, I'll have a 32 first. Here, negative 28 minus 24 is negative 52i. This becomes a minus 21. Again, there's no I now in that term. That's just a -1. And this becomes 64 plus 49. And we're almost there. Again, as I stated, the really important thing was to get this to be a real number down here, combining the like terms up in the numerator and cleaning up that denominator. 32 minus 21 gives me 11 minus 52i, and 64 plus 49 gives me 113. This is actually completely simplified, but again, I want to write this as a complex number, and all I'm going to do is apply this division of 113 to each of these terms. This is the trick. This is why I wanted this to be a real number. I can rewrite this in its two parts. The real part is 11 over 113, and the imaginary part is this negative 52 over 113, obviously times the I. And now we've divided two complex numbers, and through a little bit of magic, multiplying the numerator and denominator, thinking of this as a fraction, by the complex conjugate of this divisor right here. Once we clean everything up, specifically taking care of our I squareds, we combine our terms and then write them as these two terms. This is a completely legitimate way, by the way, to write a complex number, but this is more obvious that it's a complex number with its two specific parts.